So here I have question number 21 dealing with critical numbers. And as you saw in the previous lesson, I said that to determine critical numbers, we are really setting each factor, whether it's in the numerator or in the denominator, to 0 to determine such x values that are critical numbers. So here we have another equation. And so looking at this, or looking at this inequality over here, we can determine the critical numbers. So our critical numbers here, again, setting each factor to 0, we know 1 is just negative 5 over 2, negative 5 over 2. Then we have 1 that is 1, right, because 1 minus 1 is 0. And then we also want to look at the denominator, and we see that x is equal to negative 2 is also a possible critical number. So these are the three critical numbers that we're looking at. Now let's put this across the number line over here. And so we have negative 2.5, or negative 5 over 2, and then we have negative 2 over here, and then we have positive 1 over here. And so looking at this, we can now take any value. So we can take, for instance, 2, right, and plug 2 back into this inequality, and so we see that that's just 9, so that's obviously positive. We get a positive value here, and we get a positive value here. So overall, it's giving us a positive value. Now plugging in something like 0, right, we get a positive value here. We get a positive value here. We get a positive value here, and so clearly we have a positive value here as well, right? And then we can look at something like, so this is negative 2.5. This is negative 2, so you can put something like negative 2.25. If you want, you can do that. You can put that in your calculator, and you will see that you get a negative value here. And then you can put something like negative 3 here to determine the sign in this interval over here. So putting negative 3, you see that negative 3 plus 2, that's negative 1. Negative 1 cubed, you get something. You get a negative value, right? And then over here, negative 3 times 2, negative 6 plus 5, that gives you a negative value, right? And then negative 3 minus 1, negative 4 squared, that gives you a positive value. And so you have negative divided by negative, which is positive. So those are your intervals, those are your positives, your negatives. So now you're looking for solutions set such that your overall value for x is greater than or equal to 0. And so we're talking about greater than or equal to 0, therefore we're looking at the positive values, right? And so when we talk about our solution set over here, how you would do that is obviously you're looking at if it's equal to 0 or not. So we have something like this, negative 5 over 2. So I would say something like x is less than or equal to negative 5 over 2, right? Because if it's equal to negative 5 over 2, right, over here, then you do get 0, and that makes sense because you have this sign over here. It can equal 0, or it can be greater than 0, and saying that x is less than negative 5 over 2 makes sense because we're getting positive values here. Now looking at this, we know that everything from negative 2 onwards is giving us a positive value. However, negative 2 itself gives us an undefined value. So we're going to say that this is obviously true, or x is greater than negative 2. We're not going to say x is greater than or equal to negative 2. We're just going to say or x is greater than negative 2. And obviously the reason for that is if it was negative 2, then we get an undefined value there. But we're still using this to determine the critical number. The critical number is still negative 2, although here we're not including negative 2, despite this equal sign, because again, it gives you that undefined value. So that's question number 21, and that sums up critical numbers. So thanks for watching.